Hey guys, this is homework 10.9 and we're going to talk about two major ideas, margin of error and confidence interval. So I kind of relate these when I think about them. I relate them to like standard deviation and z-score because I think about them on like a curve. So let's just take a second to read what each is. So margin of error is an amount, usually a small amount, that's allowed for in case of miscalculation or change of circumstances. So for our unit on statistics, we'll be studying this, the margin of error will be two standard deviations within the sample proportion. I'll explain what all of that means. How does the equation for standard deviation of sample proportions relate to margin of error? Okay, so let's back up for a second. So down here is the actual equation for margin of error. So we're going to just take a second to talk about like where that really comes from. So let's just think about for a second like a normal distribution curve, and I'm just going to draw like what would be on the bottom of it. So in the middle we would have our mean. I'm going to put our sample proportion. That's what this means. It looks like a P with a little hat on top of it. So sometimes they're referred to as P hat. So we'll just call them sample proportions. So this is sample proportion. And it literally means a proportion of a sample. Okay, so on our like normal distribution curve, we would have like one standard deviation above the mean, two standard deviations above the mean, and then so on and so forth, and the same thing for below the mean. So each time that I wanted to move to get to a standard deviation above, I would add the standard deviation, or if I wanted to move below, I would subtract the standard deviation. So because the margin of error for the statistics that we're studying says that we'll take, it's kind of like we're saying we'll take any number that falls within two standard deviations of the mean. So margin of error is literally just multiplying 2 by the standard deviation of the sample proportion formula, okay? So this just means, again, 2 times the standard deviation of the sample proportion. That's all that really means, okay? So this formula is going to be very important to us, this formula right here. And it kind of goes hand in hand with confidence interval. So confidence interval, let's read over here where it says confidence interval. This is kind of how accurate the conclusions we make about a sample population are for the whole population. So if I'm trying to like make a prediction or I'm trying to figure out something that affects a whole population, but I only take a random sample to try to draw conclusions from, then confidence interval is kind of giving us leeway. So it's telling us, well, the sample that you chose might be a little bit off. So if we look in this range, then that's sure to be where the true statistic lies, okay? So, sorry to keep going, I just left off here. Sometimes the sample we get may give us data that seems like it's not representative of the whole population. So what the confidence interval does is it gives us an interval or a range that our sample data should fall into to be relevant or appropriate for the whole population. So for the statistics that we're going to be studying, the confidence interval should be 95% of the data. So that's within 2 standard deviations of the mean or sample proportion. Seems like a lot, right? Because that means that only 5% of the data we're like leaving out. So within a range of 95% of the data, like any of those could be correct. But that's what we're working with. So this goes hand in hand with margin of error, because like we just said, margin of error is really just like 2 standard deviations above and below the sample proportion. So we're really looking, our curve extends to like 3 standard deviations this way, 3 this way, but we're just going to be looking at what happens this interval here. That's our confidence interval, okay? So this sample proportion would be like the number that we really get from our data sampling, but then we're saying for the confidence interval, we're saying, well, if it could actually be any number that falls 2 standard deviations below that sample proportion or 2 standard deviations above that sample proportion. Because like we kind of talked about, taking a sample of data is not always accurate, right? So this is this formula for margin of error is how we make up for the fact that it's not always going to be accurate. This formula was created based off the fact that it's not always going to be accurate, so we're making up for it through this formula. Okay? So the last thing over here is that the confidence interval, for a confidence interval of 95%, that's not always the confidence interval in statistics, but that is what we're going to use, the confidence interval of 95%. So the confidence interval can be calculated by taking the sample proportion, the P with the little hat on top, and adding the margin of error. That will give us one side of the interval, and then taking the sample proportion and subtracting the margin of error, that will give us the other range, the other number. So we would add the margin of error, and we would subtract the margin of error. Okay? So let's actually put all of this to a problem, and that might help clarify any questions. Okay, so here we go. Example 1, 40 undergraduate students were randomly selected from around the US and asked if they planned on going to graduate school. If 6 out of 40 plan to go to graduate school, then the proportion of all students who plan to go to graduate school is estimated as blank. Okay, we'll determine that. Determine the margin of error and the confidence interval. So first thing I want to do is just underline what I think is really important. 40 undergraduate students were randomly selected for this poll. 6 out of 40 plan to go to graduate school. Okay, and then there's 2 questions here. I need to determine what the proportion is, and I also need to determine, there's actually 3, margin of error and confidence intervals. Okay, so we're doing all 3 things. So first thing I want to determine is my sample proportion. 6 out of the 40 students. 40 was a sampling, right? Obviously, there's way more than 40 undergraduate students in the whole United States. So 6 out of 40 will tell us our sample proportion. 6 out of 40. That comes to 0.15. So this, again, is our sample proportion. I'm going to label that underneath. Okay, so that also is what was supposed to fill in the blank here. Determine the margin of error and the confidence interval. Well, in order to find confidence interval, I usually need margin of error, so I'll start with that. Okay, so the margin of error, my formula is 2 times the square root of the sample proportion times 1 minus the sample proportion all over n. We didn't mention what n was. N is actually the sample size. N is actually the sample size. I'm going to go back and just write that information in. So down here where we wrote margin of error, that would be important. We want to just denote what this stands for, which is sample proportion, and N is the sample size. Okay, so in our specific question here, our sample proportion is 0.15 and our sample size was out of 40. So now I'm going to start to calculate this. So I put in square root 0.15 times 1 minus 0.15 over 40. Okay, and I'm going to start to calculate this. When I calculate everything underneath the radical, I get this number. This number is usually a little bit crazy. But then when I take the square root and multiply by 2, I get 0.1129158979. I'm going to say that's approximately 0.11. So this is my margin of error. Remember, what this really just means is kind of like 2 standard deviations from the sample proportion. Okay? So now I want to find my confidence interval. The confidence interval is going to tell me like the range of acceptable proportions for students that are undergrads that are planning on going to graduate school. So let's just make sure we understand this for a second. This number is from that kind of like survey that was put out, 6 out of 40 students plan to go to graduate school. So that means that 0.15, that's our proportion, or like about 15%. That's what this means. So what this is telling us, this random sampling, the survey is telling us that 15% of undergraduate students plan on going to graduate school. Now that's a pretty small sampling, right? So that's why we have this formula for margin of error and confidence interval, because this is going to tell us actually 15% might not be correct. I might have chosen 40 students who hate school or who are not in a undergraduate major that requires them to go to graduate school. So the 15% might not be accurate. So the confidence interval is going to allow us to find a range of numbers that would be more accurate for the whole population. So let's do confidence interval. So confidence interval, we take our sample proportion, 0.15, and I'm going to add the margin of error. I'm also going to subtract the margin of error. So I'm going to add it, and I'm going to subtract it. When I do that, I get 0.26 and I get 0.04. So remember, we are writing them as proportions or decimals, but we can relate them to percentages, 26%, 4%. So that means that a more accurate representation of how many undergraduate students around the U.S. Are going to plan on going to graduate school would be between 4% and 26%, rather than just 15%. So 0.04 to 0.26. This is our confidence interval. That's our range of numbers or range of proportions or percentages of students that for the whole population would be likely to go to graduate school if they're in undergraduate school. So where it says, what does this information tell us about the sample data? What we can write is, for the population, it is likely that 4%, or I should say between 4% and 26% of undergrad students in the U.S. will go to grad school. Okay, so again, that confidence interval is making up for the fact that we took a sample. So we weren't able to survey the whole population of undergraduate students in the United States. So we're taking our sample and we're adjusting that number to account for the whole population and not just that sample. Okay? All right, let's do one more problem. And let's look at example 2. In a random sample of machine parts, 18 out of 225 were found to have been damaged in shipment. I'm going to underline what I think is important. 18 out of 225 were said to have been damaged in shipment. Establish a margin of error and confidence interval estimate. Okay, so I'm being asked to do two things. Margin of error, confidence interval estimate for the proportion of machine parts that are damaged in shipment. Don't round, leave all numbers as they appear in the calculator. Awesome. Okay, so that's going to be hard to do, not round. So what I am actually going to do is I'm going to say, let's round the margin of error to the nearest hundredth. And let's round the confidence interval also to the nearest hundredth. Doesn't really matter, I made this problem up. Okay, so let's start out with, first of all, we need to find our sample proportion. So the sample of machine parts was 18 out of 225. 18 out of 225. So this represents my sample proportion. So that is 0.08, or you can think of it as 8%. So 8% of machine parts are damaged in shipment. 8% of machine parts are damaged in shipment. Remember that 8% though is coming from a small sample. We only sampled 225. So in order to make a more accurate in order to say something more accurate, we're going to use our margin of error and confidence interval. So my margin of error, I'm going to use my sample proportion. So I have 2 times the square root of the sample proportion, which is 0.08, times 1 minus the sample proportion over the sample size, which is 225. Okay? I'm going to do all the math here, and I'm going to tell you that what we end up getting is 0.0361724,266. So like I said, we're actually going to round this to the nearest hundredth, so 0.04. It's best to be as accurate as possible, but for the sake of just learning the concept, it's okay for now. So margin of error is 0.04. Remember, that means like about 4%. So about 4% within the sample sample proportion. That's kind of the range of numbers, or the range in percentage of machine parts that are damaged in shipment. So let's think about this confidence interval. So to find the confidence interval, we just take our sample proportion and we add and subtract the margin of error. So our sample proportion is 0.08. We are going to add the margin of error, and we are going to subtract the margin of error. Okay, so we end up getting 0.12 and 0.04. So again, let's think about what this actually means. So from just our sampling, we found that 8% of machine parts were damaged in shipment. But again, that was a small sampling. That was just 225 machine parts, and we found that 18 of them were damaged, so that's 8% are damaged. So that's kind of a big generalization to make when you take such a small sampling. So what we did was we found that the confidence interval is telling us actually what might be more accurate for the whole population of machine parts is that between 4% and 12% of them get damaged in shipment. You can expect that between 4% and 12% of machine parts get damaged in shipment. That is what our confidence interval allows us to do. It allows us to make a more accurate statistic, or parameter, we should say. Okay, guys, that's all for now, and we're going to work with this more in class tomorrow.